for this. I will give you a heads up. I realized when I was starting to save the video, it says 8.3 right here. Oops, I'm throwing stuff. It really should say 8. Oops, can't even do that. It really should say 8.4. So that is a typo. All right, now onto the back side. So we're going to make it a little bit more complicated. All right, so it says rewrite all radicals in exponential form, and then use the exponent rules to simplify, and then write your answer as a radical in simplest form and rationalize. So there's a lot going on here. So first step is here, second step is here, and third step is here. All right, so the first thing we're going to do is see if we need to rewrite this in exponential form. And you should look down, and all of them do that except for everything from 27 down. Okay, so step 1's already done for 19 through 26. And then it says use your exponent rules, which basically means how you're going to combine them. Are you going to add, subtract, or multiply the exponents? Okay, and then we're going to rewrite it finally in radical form when we're done. Okay, so we're kind of working on all these skills that we've been building up to. So right here we have to add the exponents. So we have 1/3 plus 1/4, and then you know me, I'm going to do this by hand. So we have to multiply this by 4 and 4 and 3 and 3. The question is why? Why am I multiplying this fraction by 4, and why am I multiplying this fraction by 3? Well, if we remember, to able to add or subtract fractions, you have to have the same denominator. So we're going to multiply basically by each other's denominator. We're multiplying this denominator over on the left side and the 3 onto the right side to 4. So that leaves us with 4/12 and 3/12, which is 7/12, because we only add the top, right? We can't simplify this power right here, so that's always something to look at. And then we're going to write it in radical form. Remember that the bottom is the type of radical, and this number, what goes on the inside, that's how we're going to write it. So we got x to the 7th, and weirdly enough, the 12th root of x. And we can't simplify that, because we can't make a group of 12. Okay? Moving on to number 20, same as 19. We're going to take 1/4 and add it to 3/2. This one's a little easier, because to get the same denominator, you actually just have to multiply by 2. Okay? That gets you 1/4 plus 6/4, which equals 7/4. So we have x to the 7/4 power, and then we're going to do the last step, which we're going to rewrite it in simplest form. So it's x to the 7th under the 4th root. Okay. Now 19 and 20, if you notice, the x's are right next to each other, so we just add the powers. Okay, so if you need to write this, add powers, add powers. Since we're dividing here, we're going to subtract the powers. So we get 5/2 minus 7/4. Same thing, we need the same denominator, so we're going to multiply the left side by 2. By multiplying this denominator by 2, we get that denominator of 4, so we're able to subtract them. And you get 10/4 minus 7/4, which equals 3/4. It all goes to the top, and in the last step, we have to simplify it into, put it into radical form. So it's m cubed, and then the 4th root of m. And nothing can simplify, because for it to come out of a 4th root, you need groups of 4. So since it's 3, it can't escape this 4th root. Okay, on this one, we're going to multiply. And by that, I mean multiplying the powers, which is a lot easier. I always like to say this is a power to a power, and a power to power you multiply. And that's what it's called, so we're safe. Oops, I need to do this. So you're taking 1/3 times 5/2. You can't cross multiply. Don't cross multiply. That only happens if they're equal to each other. But you can cross cancel, but there's nothing to cancel. So if there's nothing to cancel across, you just multiply from top to top and bottom to bottom. So that gets us 5/6. So we have a to the 5/6, and then we remember the number on top goes on the inside, and the number on the bottom goes with the radical. Voila, you're done. It's one short of making a group of 6, so you can't simplify it, and that's the answer. All right. Actually, I lied again. I think I'm just going to do all of these so you have tons of examples. Here again, you're multiplying because it's a power to a power. And so you're going to multiply 1/2 times 1/2, which gets you 1/4. I'll make a line here too. Okay, so that becomes 32 to the 1/4. And here we're going to have to simplify probably because we're dealing with numbers, okay? So that gets us 32 to the 1st power. I'm not going to write it because I don't need to the fourth root. So then we have to ask ourselves, can we simplify 32? Well, let's try. We're going to take 32 divided by 2, which gets you 16. Divide by 2 and you get 8. Divide that by 2 and you get 4. And divide that by 2, you get 2. 2 is the last number. It's prime. We don't need to go any farther. In fourth roots, we group up in fours. Okay, remember, square roots group of 2, cube roots group of 3, fourth roots group of 4. If it was a fifth root, it would be group of 5s. Okay, so because of this power, this index, it's how many we have to group up. So that comes out as 2 of the radical. So you get 2 fourth root of 2. And that is, I'm going to highlight it. That is your final answer. Okay, just highlight some of these so we can see. Okay, so number 24. I want you to try this as much as you can. Okay, it's a little bit different than what we've done on all of these up here, but you're definitely capable of doing it. My hint to you is you have to multiply powers. And my hint to you is, another hint is it's 8 to the first power. So you have to multiply the 2/3 to the 8 and to the x. And then you're going to do everything pretty much the same, right? So let's see how far you can get without my help. So pause the video now. All right, now that you've restarted this video, we're going to go through all the steps of how to do this. The 2/3 goes to 1, so we just know that's 2/3. And we're going to take 2 times 2/3. Well, we know 2 is the same thing as 2 over 1, so that gets you 4/3. Okay, so you have x to the 4/3. You do not need to make these separate radicals, so let's talk about that. Since they have the same base, right here and right here, you can write it all under one radical. No need to separate it, okay? So they're both cube roots, except for this one's 8 squared, and this is x to the 4th. All right, so let's simplify this 8 squared. That gives us 8 squared is 64, and then we have x to the 4th. So let's simplify 64. Now, when you're doing this, you're looking for groups of 3 of whatever you have because it is a cube root. So 64 is divisible by 2. That gets us 32. We divide that by 2. We're all the way back over here. You get 16. Divide it by 2 and you get 8. Divide that by 2 and you get 4. And divide that by 2 and you get 2. So there's a group of 3. There's a group of 3. So what this is saying is 64 is a perfect cube because there's nothing left over. So we're going to kick out this 2 and that 2. So if you multiply together, you get 4. And then we have to ask ourselves, can we make any groups out of this 4? Well, 4 divided by 3 is 1 with a remainder of 1, right? 1 left over. So we have x, and then we'll have cube root of x. And that is your answer, okay? All right. Now we need to remember what happens with negative exponents. Okay, so negative exponents flip. Okay, they don't make it negative. Don't make negative. I'm going to highlight that. You do not make it negative. You just flip. Okay, so you just flip the value. So we have, and when I say flip, let's go over that more. We know 100 is the same thing as 100 over 1. That power's with it. So we flip it, it's going to go from the top to the bottom. If it was negative on the bottom, it'd go to the top. So now we have 1 over 100, to the 1/2 power. Okay. When you flip it, the negative goes away. All right, so that's the whole point of the flipping process. And then we have to figure out what is 1/2. Well, that's 1 over 100 to the first power, which I want to write, and the square root of it. And hopefully it's clicking because the square root of 100 is 10. Okay? So 26 is kind of like 25, but it looks a little bit more complicated. The first thing we're going to do is take care of this negative. And if you take care of that negative, all it does is it flips the fraction. Okay, that's what we did over here. We flipped the fraction. It was 100 over 1, and now it's 1 over 100. So we're going to get rid of the negative and flip. So we get 7 over 112. And there's tons of different ways to go about this problem. This is just the way I decided to do it, and there's nothing wrong with that. Okay. So then you have to take the square root of this. Now you can think of it in 2 different ways. You can think of it as, I'm going to write it over here, as one big square root or separate. So if we think of it as one big square root, it's 7 over 112, which is okay. I'm going to think of it as separate because I know I'm dividing and I'm going to have to do something else, okay? if you looked at the top, it says rationalize if needed. Okay, well, because there's a radical on the bottom, or you're doing some kind of dividing, you're most likely going to have to rationalize. Okay, so that's the route we're going to have to take. Now you can simplify this radical first. You really can, or you can just multiply by the square root of 12. That is completely up to you. I'm going to just multiply first, okay? And then my bad. Oops, erase some things. And then simplify the radical after the fact. Not saying that's the right move. It might be more work. I don't know. Okay, but this is just the route I'm going to take it. When you rationalize, one rule is you're not allowed to have a radical in the bottom. So to get rid of that radical, you multiply by a radical. Okay, so you're going to multiply, remember, the inside with the inside and the outside with the outside. So you're going to take 7 times 112, and that gets you 784. And when you take a radical times a radical with the same number, when you take a square root times a square root, that's important, times the same number, you just get whatever's underneath because it cancels out. And then because 784 is such a big number, we are going to, I'm going to write a line here to separate work. We are going to have to simplify the 784. And that's a big number, so this is going to be a process. We're going to divide that by 2, and you get 392. Divide that by 2, and you get 196. Now, some of you might not be able to notice something about 196, but if not, that's okay. We're just going to keep on going. That gets you 98. Still even, so we're still going. Divide that by 2, and you get 49. You might be able to notice something about 49 here. 49 is not divisible by 2, but it's divisible by 7, which is prime, right? And we're working with square roots, right? The 2 here, it's a square root. So we're coming out in pairs. So that's a pair, that's a pair, and that's a pair. Since nothing's left over, that means that this is a perfect square. Okay, so you could have taken the square root of 784 and got an answer. This comes out as a 2, this comes out as a 2, this comes out as a 7. So if you multiply the 2 and 2, that's 4, and multiply the 4 and the 7, you get 28. So we have 28 over 112. And then we're going to simplify that fraction, and I'm just going to use my calculator, but you can divide everything by 28 actually. If you take this divided by 28, you get 1, and if you divide that by 28, you get 4. So the answer out of all of this becomes 1/4. Kind of crazy. Okay. I feel like I'm just rambling on with this. There's a lot of examples on this back side, so I'm doing a lot. So this is kind of a long video. All right, I told you 27, 28, 29, and 30 are different, and that's because it didn't start like these in rational form. It started as radicals. So you need to actually do more steps. So we have to rewrite it as radicals. So write as radicals. So starting here, there's a power of 1. So it's v to the first power, and then it's a cube root, so 1/3. And then this is a square root. There's nothing written. It's v to the first power. So we have v to the 1/2. So that looks a lot like 19 and 20. So what I would like you to do is go ahead and simplify this on your own. My hint to you is you're adding. So I want to write this here. This is flipping. You flip. Okay. So we're going to add the powers and simplify. So go ahead and try this problem on your own and pause the video now. Okay, now that you restarted the video, let's go ahead and do this, okay? You're going to take 1/3 plus a half. You need to get the same denominator, so I'm going to multiply by each other's denominator because it's nothing I can multiply up to. So that gets you not 2/3. What am I thinking? 2/6? I don't know why I did that. And you can write that fraction symbol there if you want. So you get 2/6 and 3/6, which gives you 5/6. So it's v to the 5/6 power. Okay, the power on the top is the inside, or the outside is what we learned, and the 6 is the radical. So that is that. Okay, I'm not going to do 29. I'm going to do 28 instead. So this video is not forever long. And I'm also going to go like this because I kind of use a lot of room. Okay, so we have 4. We're just going to go like this and kind of ramp off that. Okay, so we have 4 to the first power divided by, if we rewrite this, the power of the 4 is 1, and the radical is 3, so we're dividing by 3. okay? So what we have to do here is subtract the powers. So we're subtracting it. So we're taking 1 minus 1/3. Well, I'm hoping that you know that's 2/3, but if not, you get the same denominator. So it's 3/3 minus 1/3, which is 2/3. So we get 4 to the 2/3 power. Okay, anytime this is a number, we're probably going to have to do some simplifying. That makes it 4 squared on the inside and the cube root on the outside. So moving down over here, we're going to square the 4, and you get 16. Now just remember, if I'm moving too quick, you can always pause the video, okay? You don't have to try to play catch up. The great thing about this is that there's a pause button, okay? So moving on, we're going to take 16, divide that by 2 because we have to simplify it. That gets you 8, divide that by 2 and you get 4, and divide that by 2 and you get 2. So I'm looking for pairs of 3s because it's a cube root. That 2 is going to come out, but the other 2 is going to stay because there's not another group of 3s. And that's your answer, okay? All right, last one, because we're skipping 29 because it's pretty much exactly the same as 28. All right, we're going to put whatever's in the parentheses, whatever in the inside, like in parentheses. Okay, so we have 25m squared. Even though there's a power here, technically this whole set of parentheses is to the 1 power, and it's divided by 4 because it's a 4th root. Okay, from there we're going to distribute. So we're going to take 25 to the 1/4 power, and it's 1/4 power because the power is 1 if it's not written. And then we're going to take the 1/4 power to 2. Like this again. So we're taking 2 times 1/4, which is the same thing as 2/1, and that becomes 2/4, which is 1/2, right? Multiply 2 to 1, 1 to 4, and you get 1/2. So now you have m to the 1/2. Well, we're going to realize something, okay? This right here has a different radical than that, and that's okay, right? So we're going to have to think of them separately. So we have 25 on the inside, and the 4th root of that, right? And then this right here is a square root, so times, and then the m is to the 1st power, and then it's the square root. So this is equivalent to what the answer is. Does it almost make it more complicated? Yes. Can we simplify the 25? No, because 5 and 5, you only get a pair of 5s and not 4 of them, and you can't simplify this. So that is your answer. Okay? If you have any questions, get a hold of me. Hopefully that helps. There's only 2 Khan Academies, so you should be good. Stay healthy, stay safe. See ya.